Hello everyone, we are continuing with the next experiment. It will be the number 8 experiment. So we will use both of them, both amplifier 1 and amplifier 2. So I will calibrate at the first. If you remember, I was common to the 0 and output of the amplifier to amplifiers 1's output to the voltage reading, and gain course and gain fine multiplication will be 100, so it will gain fine will be 1.0 and gain course to the 100. Now I am reading a voltage value. I will set that value to 0. So I will turn the offset and I will make it 0. Okay, this seems nice. So again, now gain course is 10 and multiplication is 0.1. So my gain is right now is 1. And for the second amplifier, I will use this as an impulse signal. So I will arrange this around 2.5 volts. Again, I am arranging to 100 multiplication result, and I am arranging the value to, okay, it seems good, 2.35. And now I will try to do the position control of the DC motor. I will start with arranging my cables to the Y1 track, and I will arrange my reference points, so I will get the values from positive 5 to C of Y1 track and negative 5 to A, and to the middle point I will arrange it to 0 voltage. So I am arranging the potentiometer voltage to 0. This means when I set my build, the position of the DC motor will be at the 0 degree. Okay. I will connect another cables to my system, and P goes to the differential amplifier. P goes to differential amplifiers A, and amplifier 2's output goes into differential amplifier input. So I am getting another cable, and amplifier 2's input, by the way, I have arranged to amplifier 2 as gain as 1 again. So differential amplifier B side, and output of the differential amplifier goes to the input of the instrumentation amplifier's positive side. Output of the differential amplifier goes to instrumentation A, and instrumentation B is connected with DC motor servo potentiometer. DC motor servo potentiometer's output goes to instrumentation amplifier. This is my feedback, in fact. And if I continue from here, the output of the instrumentation amplifier, the first one goes to integrator input, and integrator's output will connect to the summing amplifiers A, and the another output of the instrumentation amplifier will go directly to summing amplifier. This will be P control, this will be I control. So when we sum it, now we can say that this is PI control. And another controller is our differentiator for the PID control. So several potentiometers output will go to the differentiator's input, and if you catch from here, differentiators is connected to differentiator output connected to inverter's input, and inverter's output goes to the summing amplifier. Now it's completed. This is right now PID control. Then we will continue with summing amplifier goes to amplifier 1. To amplifier 1's input, amplifier 1's output goes to, okay, I can get this smaller if I can find. Never mind. Power amplifier, and power amplifier's output goes to the inputs of the DC motor. And I can plug more coil meter to observe amplifier's two's voltage or output value. So I am making a short between minus to 0 and positive to output. Okay. Now it seems ready. I'm checking again if I missed anything. So 2.1, I have arranged my amplifiers calibration. Then I will change control to 10 and 30 degrees. Okay. 2.2 P control. For the P control, I will unplug again the integrator and differentiator. So from the differentiator, I am unplugging the inverter cable to summing amplifier and integrator's output to summing amplifier. I removed this two cables, so this is now my P control, and I will set my amplifier 1 gain to, I will start with gain 1 and I will check gain 5 and finally it will be gain 10, and I will check it out that if my system has any continuous running, or continuous running, is it infinite loop or just going somewhere, and I will just observe with my eyes to my response time and number of oscillation. So I am starting right now. Now gain 1, I am giving my impulse, it's 0 right now. It's nearly 270 or minus 90 and minus 90 degree. Okay, it seems that I can feel my blanks right now. Continuous running is no, there is not. Response time, in fact it's a fuzzy term, so I cannot say anything before I see for the gain 5, but I can assume that from the mathematics or control background it will be slow, but I'm not writing right now. And number of oscillation is no, there is not any. So now and again gain 1, and as you remember from the second experiment, if I'm not wrong, you will remember that zone problem. So I'm just arranging with my finger sometimes to degree, it's 0 again. And now gain is 5, I've arranged, and I'm giving my impulse right now. Okay, as you see, continuous running is no, response time is faster, so I will say this is slow, this is fast, or maybe normal, because I haven't seen anything about gain. And number of oscillation is, it goes to 210 to back again. Okay, number of oscillation is 1, I can say. And again, getting my impulse to 0, again 1 gain. I'm arranging to 0 with my hand, and now amplifier 1's gain is 10, and now I will make an impulse. Okay, now it's not finding its value, so I can say that the continuous running is yes. Response time, yes, it's faster maybe, but number of oscillation is infinity. I'm decreasing my gain again, and pulse is 1. Arranging my degree with my hand. Okay, P control is done, so I will continue with PI control. So I will plug integrator's output to summing amplifier's input, and I will start with 10 seconds. Okay, gain 1. Now gain will not change. Gain is, all of them will be 1. Just I will change the time constant of the integrator, and I will start with 10 seconds. And again, the problem is continuous running. If my system have any continuous running, response time and number of oscillation. So again, I am giving a impulse response. It goes to nearly 31, and yes, now it's reaching its set value, but it's very slow. I can just run continuous running with 10 seconds. No, response time slow. And now yes, it's reached maybe 25 seconds. So number of oscillation is no, not any. Now I'm arranging my amplifier to 1, my degree to 0 with my hand, and now arranging 1 second. Okay, now my impulse response, it goes to 250s, and now removing back. So I can say number of oscillation, yes, only 1. My system have, it's maybe normal, not I'm writing fast right now, but it's faster than 10 seconds, and continuous running wrong. And if you wait enough time, you will see that it will be 270 degrees. Then I'm arranging my position to 0. I will reset. Okay, now it's 0 and 100 millisecond experiment. All things ready, so I'm giving my impulse response to my system. It's fast. There is an oscillation, and my recovering time is a bit, again, it's long, but it doesn't important right now. Continuous running, no, it's fast, and again 1. Now I will reset this to my system, arranging, doing my calibrations. Okay. Now I'm unplugging integrator, and I will connect differentiator to PD control, so from inverter's output to summing amplifier. Now my system We'll start with 1 second, then 10 milliseconds, and finally 100 milliseconds. We'll start with 10 seconds. Okay, gain 1 and gain 1. Now I will impulse my system again, starting with 0. Okay. It's slow. Very slow. And amplifier 1 is my gain. Amplifier 1 is 1, so my depth band zone is a bit wider. So sometimes it's not reaching my set value. Okay. Continuous running, no. Response time, slow. And number of oscillation, there is not any. Okay, again 1, and I am just removing the system. Okay. Now it's ready for second experiment. 10 milliseconds. Okay, I'm giving my impulse right now, and it's faster. It's not removing back, so I can assume that I have no oscillation and not continuous time. Continuous running, no. It's normal. And number of oscillation, there is not any. Okay, I'm just fast unplugging this, unplugging, and my system will go to 0 again. And now it will be 10 milliseconds. It's nearly, I can say that, yes, maybe a little faster than 10 milliseconds. No, fast, and there is no oscillation. Okay, PI and PD control is done. Now I will plug all of them. I will combine with PI and D, so it will be PID. Now I'm arranging my system from here, and I was removed the integrator, so I will plug this to sounding amplifier. Now it's completed, it will be PID control, and if you see from here, integrator will be 10 seconds at the beginning. I'm arranging it. Then I will change differentiators time. I will start with 1 second, then 100 millisecond and 10 millisecond for all integrator value. So it will be 9 experiment right now. Okay, I will start with 10 second, 1 millisecond. I am checking out again. Okay. Now this is PID. Seems that I have no oscillation and it's slow, and there is not any continuous running. Okay, no, slow, and there is not any oscillation. Now again goes to 0. Okay. For 100 millisecond of differentiator. Continuous running more. Response normal. And number of oscillation, there is not any. And now I will again to 0. And 10 milliseconds. It's fast. No continuous running. Fast and number of oscillation, it doesn't seem any with my eyes. But if we wait enough, if we wait very long time, maybe if we can see that only one oscillation we may have in our system. So, or just one, I can say. Okay. So for integrator is 1 second and 1 second to differentiator. Again, I'm doing my arrangements. Okay. All right. Now I have an oscillation. It seems now one oscillation. I cannot say it's slow or fast right now, but there is not any. But after 100 milliseconds, I can compare that term. Second, yes. Okay, so if this is slow, this might be normal. No, and again, yes, I have an oscillation. Again, it seems one oscillation. Okay, and 10 milliseconds. Okay, I will repeat this again. It might have any I might wrongly push to 1 second. Okay. In fact, it's nearly the same. Okay. And now 10 milliseconds and 10 seconds. It seems no oscillation. Fast and no. Now it will be 100 milliseconds, and this will start again at 1 second. I'm resetting. One. No. Normal. And one. Now I have continuous running. No. In fact, this will be faster than this. And number of oscillation is 2. And now it will be 10 milliseconds. Finally. Continuous running, yes. Infinity. This is the end of 8th experiment. See you at the next experiment.